Okay, so this is the first problem. My screen is visible, right?
Yeah.
Okay. Okay, so this is the first problem. In this problem, initially we are given n integers, which are all equal to 1. And then in each turn, Alice and Bob will choose at least 2 equal integers and they'll wipe them off from the board. And instead of those 2 integers, they'll write the sum of those 2 integers. So Alice starts first, and whoever cannot make a move wins. So let's see the cases when Bob will win. See, if we have, suppose we have some X number of ones, what I can do, Alice will just remove X minus 2 ones, and the sum will be nothing but X minus 2, right? So if X minus 2 is not equals to 1, in that case, Alice will always win. Why? Because then I will have something like X minus 2, 1, and 1. Bob will have only one move, that is removing these 2 integers. So if Bob removes these 2 integers, I will have something that is X minus 2 and 2. So if Alice doesn't, like we want that Alice shouldn't have any moves, so X minus 2 shouldn't be equals to 2. Because if X minus 2 is equals to 2, that means I'll have 2 and 2 written on my board. So then also Alice will have one move. But if X minus 2 is not equals to 2, that means X is not equals to 4. So let's consider these cases when I have 2 integers, 3 integers, or 4 integers initially written. Because for all the integers, that is 5, 6, or anything, I'll just remove n minus 2. Alice will just remove n minus 2 integers in the first move. And then I will have something like n minus 2, comma 1, comma 1 written on the board. Bob will have only one move, that is n minus 2 and 2. So for all of these values, this thing is not going to be equal. Like I cannot have any further move to be made, right? So Alice will win. But let's see these cases when my n is 2, 3, or 4. Initially, when n is equals to 2, I will have this thing. So Alice will make one move and I will have 2 on my board. So now Bob doesn't have any move because there is only one integer, right? So in this case, Bob wins. Now let's see when I had three integers written on my board. So I have something like this. So Alice makes one move and I have finally 2, 1. Or maybe he selected all the 3 integers. So I will have 3, just 2, 1 or 3. So in both of these cases, Bob wins, right? And if Alice had 4, like initially there were 4 integers. So either Alice could do something like 2, 1, 1, or maybe 3, 1. Like Alice selected the first 3 integers, or 4, 1, or just 4, right? So in these two cases, Bob wins immediately, right? Because Bob doesn't have any of the moves, valid moves. But in this case, when there is 2, 1, 1, so in this case, when there is 2, 1, 1 on the board, Bob will select these 2 integers and there will be finally 2, 2, and Alice will then again Alice will have to make a move, right? So now Alice will give Bob something like 4. So in this case, also Bob doesn't have any valid move left. So in this case also Bob will win. So Bob only wins when my n is 2, n is 3, or n is 4. In all the other cases, there is a winning move for Alice. Alice will just remove the first n minus 1 elements. Is this clear?
Yes.
This is clear to all, right? Bob only wins when my n is less than or equals to 4. In all the other cases, Alice will win. Okay, if anyone has any problem in the approach, let me know. Otherwise, we'll move to the implementation part. You can unmute yourself and let me know if you have any doubt. Okay, so let's look at the implementation. So this is the implementation. I take n as input, and then I finally check whether or not my n is less than or equals to 4. If my n is less than or equals to 4, I'll output Bob, otherwise I'll output Alice. So now let's look at the second problem. So this is the second problem. In this problem, I'm given that an array is beautiful if it is possible to remove some elements from the beginning of the array and insert them in the same order at the ending of the array. And then the final resulting array should be sorted in non-decreasing order. So I'm given elements like 3, 7, 7, 9, and each time I have to, if it's after inserting this element at the end of my array, if my array is still increasing, like it's still beautiful, then first of all, I have to insert this element and I have to output 1. Otherwise, if it's not giving me a beautiful array, I won't insert this element or append this element at the end of my array, and I'll output 0. So is the problem statement clear?
Yeah, please re-explain it once again. Actually, I wrote the code but got wrong answer. So
Okay.
can you just explain it once more?
So these are the elements and elements given to me. You have understood what is the definition of beautiful array, right?
Yeah, if we can remove first few elements and append it, then if it is increasing, then it is beautiful.
We can remove some of the elements from here. Let's say X, Y, and Z. These, like, it's not fixed that I have to remove 3, like any. If I can remove any elements, any number of elements from the beginning, and I append these elements at the last in the same order, X, Y, Z, and my array is sorted in non-decreasing order, then it's said that this is a beautiful array. Now I am given n integers, and if, let's consider at the start my array was, it had none integers, like it had no integer, then I'll try to append this element at the end of my array. And if my array is beautiful, after appending this element, I'll first output 1, and I'll then append this element actually to my array. And if after appending, suppose this element, my array wasn't beautiful anymore, then I'll output 0, and I won't append this element. So finally, I have to output all of these 1, 0, 1, 0, 1, 0 once for all the elements, after appending which element I had gotten a beautiful array. So now is it clear?
Yes, yeah, but why do we have to append or not append? Means
like if it's beautiful, if it's giving you a beautiful array, then append it, like it's given in the problem statement. Okay. So what we can do, we can simply check if our value is simply increasing, like the value that we are trying to append is more than the value which was appended last time. So then in that case, we can simply append it and output 1. But suppose this is the first time that I'm getting less than the value that had appended last time. Now, why I'm saying this is the first, like, okay, let's discuss it a bit later, but let's say that I'm trying to append something which is less than my value that was appended last time, and it should be, since after like these elements will come maybe probably at the end, so this should be the value that I'm now trying to append. Let's say first I appended this value, then this. These are the values, right? These are the magnitudes of these values. So my values were increasing. Then after some time, I tried to append a value which is this thing, which is, now let's say it is like this thing, which is smaller than this value. So for this value, I can still append this. Why? Because I'll simply move all of these elements after this thing, right? But if I have to append something which is maybe more than my first element, and it's less than my last element which was appended, then I cannot append this. It won't give me a beautiful array, right? Because you cannot arrange these elements by somehow moving the elements from beginning to the ending such that your element array would be sorted. Because you simply have an element which is more than this, which was appended last time, then you have something like this, and the first element is also lower, like it's less than. There are some elements here, and this is less than this element. So even if you try to bring this element after this element, you will have something like this. This is not sorted in increasing order. So that's why, first of all, keep checking that the element that you're inserting or appending, it should be more than the last element. Suppose this is the first time that you got an element which is less than this element. So simply check, it should be more than, not more than, it should be less than your first element.
That means less than equal to.
Sir,
Yes,
can
then
you
it
please repeat this statement once more?
Okay, you have to check for, like, first of all, just check that till when you are getting elements in increasing order, increasing or non-decreasing. Like these elements are something like 5, 5, 6, 7, and then you got a 3. So 3 is less than this element. So first time when you get an element which is breaking your sequence, like it is not more than the last element that was appended. So simply check whether or not it is less than the first element or not. If it is not less than, then simply you cannot append this element at the end of your array. So output 0. For all of these elements, you had outputted 1. Now, suppose this was less than the first element. So you output 1 and you append this element at the end of your array. Next time, since you have this condition is once true, so now you don't have to check simply that this element should be more than the last element. You'll also have to check that the element that you are appending now, it should be less than or equals to this element. Now all the elements after this conjecture, like after this position, because since you already have broken your non-decreasing sequence, so now all the elements that will be appended, you need to check for two things. It should be more than or equals to the element which was last appended, and it should be less than or equals to the element which is at the first position. Is it okay? I think this.
So yeah, I'm unable to get this part. And this after breaking the sequence, why do we have to check two conditions?
Okay, because see,
I got first condition, but
because see, after,
not the second one.
Suppose you had elements like this and then you inserted this element. So after this, you have to check two conditions, that the element that is appended next should be, first of all, more than or equals to this element, and it should be less than this element. Because if I append this thing, let's say this is 5, this is 7, this is 9, this is 1. So after this, if I append 6, can you really place these elements after this element that you'll get a sorted array? No, right? It will be 5, 7, and 9. So this is not sorted. But if you had something like 3, which is less than 5, less than or equals to 5, and more than equals to 1, then your array would have been sorted, right? So that's why after this condition is once met, you have to check for two things, that the element which is appended next should be more than equals to the last element and less than equals to the element which is at the first place, 5. Is it now clear?
Yeah, it's clear. Okay.
Is anyone else have any doubt in this part? Like if you'll try to do this with a pen and paper, you'll feel it more intuitive. Once you reach this point, you'll have to check for two things.
Sir, if we have two consecutive numbers which are same, like the first number is 5 and we get a number which is smaller than 5.
Yeah.
No. We get a number after breaking the sequence, we get a number like 2, which is smaller than 5. And we get again 2. So can we take the next 2?
Yeah, we can take both of these 2s, right? Because I'll simply move this 5 afterwards. So 2, 2, 5.
Okay,
so that's what I'm saying, less than equals to and more than equals to. Okay, so if it's clear, we'll move to the implementation. So this is the implementation. First, I'm taking my array A as input. Then I've declared my string answer. And X is nothing but for me to check what is the, like till now, what is the array that I have generated after appending elements, right? So for each element of A, I'm checking if this is the first element. That is, my answer doesn't have any size till now. So I'll simply push this element into my array. I'll append this element into my array, x dot pushback A of 0 and answer plus equals to 1, because this is beautiful array. Right now I have a beautiful array. Now what I'll do then, for each of the next elements, I'm simply doing if E is more than, that is, E is nothing but the current element. If it is more than the last element which was appended, and it is not okay. Not okay means I have not really arrived at a position where my sequence got broken. Like
Bhaiya, why did you insert 0, A of 0 in
A of 0? You can do E also here. Like this is the first element. X dot pushback E also. Like first element. For the first element, anyway, for the first element, your array is beautiful, right? After appending.
Okay, A array has means the queries.
Yeah, A has queries, array A.
Okay.
Okay. So now this element is more than the last element, and it is not okay. That means I have not arrived at that position when my array from non-decreasing decreased for the first time. So I'm simply pushing this element at the end of my array, and I'm appending 1 in my answer string. Otherwise, I'm checking that, okay, I haven't really like arrived at that position, but for the first time, my current element is less than or equals to, like, it's not like, this is not true. So this means that my current element is less than x dot back. So now my current element is less than x dot back. I'm checking that it is also less than x dot front. That is the first element that was appended. So if both of these are true, I'll mark my OK as 1. So this is that I have arrived at that position. And then I'll append this element at the end of my x vector, or my array that is I'm generating, and answer for the current element, I'll append character 1 in my answer. Then after this, I'm simply checking if I had already arrived at that position, then I'm checking for these two conditions, right? That the current element should be less than the element which was appended last time, and the current element should be less than the correct element which was appended for the first time. If both of these conditions are true, you don't require actually to do this OK1 again, but you can like simply push this element in my x vector. You can push this vector like element in x, and then again for the current element, answer will be 1. And otherwise, for all other cases when none of these conditions met, you can simply append character 0 for your answer, and finally print your answer. So you just follow those conditions, then you can implement this in any way. So I have implemented it like this. There are many ways to implement it, but just focus on these conditions. Like if you have arrived at that positions 1, like your non-breaking, non-decreasing sequence is once broken. So you need to check for 2 things. Otherwise, just check for 1 thing. And this is the condition when my sequence is breaking, non-decreasing sequence is breaking for the first time. So is this clear?
Yes.
Okay.
Yes.
So let's look at the third problem. Okay, this is the third problem. In this problem, we are given a string having A, B, C, D, and E. And finally, we'll have like value of A is 1, value of B is 10, value of C is 100, value of D is 1000, and value of E is 10,000. So for this, you'll have to for computing the value of this string, what you have to do, you have to iterate this string from right to left. And when you are at characters, let's say A, you'll have to check whether there is a character that is bigger than this. Like there are from character A, character B, C, D, and E are greater, right? So you'll have to check whether there is a character which is more than this appearing on the right side of this character. So if it's true, instead of taking its value as positive, you'll consider its value as negative. Like here, you're considering it as -1. Otherwise, you would have considered it as +1. So finally, this is the value of this string. So now you are given that you can change any one of these characters to any other character, like among A, B, C, D, E. You cannot make it F, right? But you can change any of the characters in the string as A, B, C, D, or E. So you have to tell what is the final value that you can get. So what we can do, this is a simple DP problem. So your DP will have 3 states: your current index, the character you are considering for this place, and whether or not you have changed. What? Like your voice was breaking. Somebody was saying something.
No, I don't have any. Sorry.
Okay. So DP, this is your 3 states of the DP. The first one is the position. Second is the character that you are considering, like either A, B, C, D, E, or F. And the last one is whether or not the current character is changed or not. But it's like the problem statement. First of all, is the problem statement clear to everyone?
Yes.
Okay. And is the approach clear? Because once the approach is clear, then it's nothing. From this point, if this is done, you can simply check for I. If the current character wasn't changed, you have an option to change the character afterwards. So the value will be nothing but the value that this thing has contributed, plus if there are any characters that are bigger than current value, right? And you'll have to start from right. Like, how will you get to know that whether a character? Okay, so this thing will give you the maximum character that has appeared till now. So what you will do, suppose this is your string, iterate it from right to left. Why from right to left? Because how will I know? Suppose I am at this position, you'll have to know whether or not there's a character bigger than A or not. So that's why I'm iterating my string from right to left. And then simply check that, okay, if whether or not you can change or not. If you have already changed once, then you cannot change because it's allowed to change at max once. Right? And then simply check, okay, what is the maximum? This is the character, right? Max character that appeared. So simply do if current character, if you are not changing, if it is less than max, then the result for this will be calculated as negative value. And if it is more than max or equals to max, like if this is D and only D appeared after this, so then also its value will be considered as positive. So just compare this thing, and then if you can change, like this value was, you can actually change this character right now. So you have an option. So try for all of these values, A, B, C, D, E. Try for all of these values and continue leftwards. Okay, yeah, I also tried greedy and my greedy actually passed, but it wasted a lot of time. That's why I'm not actually getting into greedy. Like if you want, I can show you my greedy solution and you can match that solution with the DP solution. You'll find like it's very clean. So this is a DP solution, right? This thing. And now let me show you my greedy solution to you. This is my greedy solution. Like this also has passed, but still see. So I had to do all of this to get it passed. So that means that this solution wasn't actually meant to be, like this problem wasn't meant to be solved using greedy. It is much easier. Like you can solve it, but considering problem C of diff2 and this much code, like this really doesn't make sense. Like I really wasted a lot of time in this problem debugging it, because there are many corner cases and then you have to compute it correctly. But anyway, Therefore, I'm not discussing this code with you, the greedy one.
In contest, you solved DP1.
No, I did with greedy in contest. So, okay, let's look at this. So this is nothing but int index. What is the maximum that I have achieved till now? And can I change it or can I not change, right? So then I simply am doing if the value of this thing was calculated earlier. So I'm simply returning it. Otherwise, my sign for this is if the character at this index is less than the maximum which has appeared at somewhere at the right of this. So my sign will be simply negative. So my result is sign into this value plus all the values that are like I'm computing for index -1 for the values that are appearing at the left of this, right? And I'm taking my max element will be now maximum of the max element that was till now or the character that is at the current index place, inth index, right? And this is same as whether or not I had changed. If now, suppose till now I haven't changed any character. So I have an option to change the correct character. So I'm trying to get it like for I is equals to 0 to 5, it's simply A, B, C, D, and E. But if my current character is same as this, like A means 0, B means 1, C means 2, D means 3, and E means 4. So if this is same, like I'm really not changing anything, right? If I'm doing this, so then I'll simply skip this part. But if it is not, then I'm changing my character. So what I'm doing, I'm again computing sign. How I'm computing sign, then my current character will be this thing, right? So if I is less than max, I is my current character now. So if I is less than mx, my sign will be minus, otherwise my sign will be positive. So in this case, my result is maximum of this thing. And then again, I'm returning dp of index mx change and result. Okay, is it clear? Like the DP solution is pretty straightforward, right? Okay, somebody asked me that, can you please, okay, the time complexity for this is nothing but n times, what is max? Max is 7 times 2. So it will anyway pass. Okay, somebody asked me that, can I please replace? Okay, first of all, if you have any doubt, you can like unmute yourself because sometimes I might skip your comments in the chat. Okay, so yeah, I'll discuss D also. Can you please replace problem B with, like replace B with E in first test case and calculate answer? Okay, just wait for a minute. What is the first test case? The first test case, DAA. DAA. BDCA. We're talking about this test case, right? Whoever asked this. Like you can unmute yourself and let me know.
Yes.
Okay, so which B are you talking about? This B, right?
Yes.
So if you replace with this with an E, the value of this thing is going to get negative.
Negative.
And this was negative earlier. You were getting minus 110 because of this. Then you'll, if you replace it with E, you'll get plus 10,000. And this will turn out to be minus 1,000, right?
Yes.
So it's better that you replace this with E, because in that case, your minus 1,000 will go and plus 10,000 will come in its place, right? So these two are same. These with this same, but you are getting a -10 extra if you replace this with any. So that's why it's better to replace this t with any. Is it clear?
Yes, yes.
Okay, so let's look at the fourth problem. Okay, is the problem statement visible to you?
Yes.
Okay, so in this problem, we are given some n segments, and 2 segments are said to be intersecting if they have a common point in their range. So we are given that, okay, an array of segments is called beautiful if, first of all, the size of that segment is even. That is, there are even number of segments in that array. And then you can like divide this segments into k by 2 pairs. Like suppose k was the size of the array, you can divide all of those segments in k by 2 pairs. So is this clear what the problem statement is trying to convey here? This is clear, right?
Yes.
Only this part. Okay. Then once you divide these k pairs, like k segments into k by 2 pairs, the two segments that belong to one pair, they should intersect first of all, and these two segments in the current pair, they shouldn't intersect with any other segment in any of the other pairs. Okay, that's it. And finally, we have to find, okay, how many minimum segments we have to remove from our array such that our final array of the remaining segments would be beautiful. So let's look at see. Suppose I had some segment. This is intersecting, but suppose I had another segment like here. So now this is intersecting with this thing, and this thing is intersecting with this thing. So if I keep these two as a pair, like, and I also select this segment, and this segment maybe is intersecting with this thing, so I cannot have these two pairs, right? Why? Because these two segments which belong to two different pairs are intersecting with each other. So that is what I have to do. I have to remove some segments. In this case, probably remove both of these segments, because you cannot even have a single segment. You'll need to have a pair, because k should be even, the size of the final array. So finally, you'll have this answer. If something like, let's have these numbers 1, 3, 2, 4, 3, 5, and 5, 7. So you'll have to remove either these two, or you'll have to remove these two. But like anyway, you'll have to remove two segments in this case. So now this problem can also be solved using simple TP. Since our n is going up till only 2000, what we can do, let's have our dp as dp of I, comma, selected or not. So this is index of the current element, and this will tell me whether or not the current element was selected or not. 0 if it is not selected, 1 if it is selected, and dp of I, comma, selected will give me the maximum number of numbers that I can select. And finally, my answer will be nothing but n minus dp of 0, 0. Okay, let me write it again. My final answer would be, once I have calculated all my dp values, it will be n minus maximum of dp of 0, 0, dp of 0, 1. So what is this? This is nothing but like n minus n were the total elements that are available to me. dp of I, comma, selected is nothing but how many numbers I can select, how many segments I can select how many segments I can select starting from ith segment, and select is basically either 0 or 1. 0 means the current segment is selected, 1 current segment is not selected, and 1 means the current segment is selected. So basically dp of 0, 0 will give you starting from the 0th index segment and not selecting it, what is the maximum number of segments that you can select. And dp of 0, 1 is nothing but starting from the 0th segment and selecting the first segment, that is the 0th index segment. What are the maximum number of segments that you can select to get a beautiful array? So maximum of these two minus n minus this thing. So that is the number of segments that you'll have to remove. But how to actually calculate this value? See, if I am at index I and I don't have to select the current segment, so then I can simply calculate dp of I of 0 is nothing but maximum of, you don't have to select this element, this segment. So maximum of dp of I plus 1, comma 0 and dp of I plus 1, 1. So this means just move to the next segment and try selecting it, like try not selecting it and try selecting it. Whatever is the maximum value that you'll get, give it to this. You're not selecting the current segment. But now let's say what will be dp of I comma 1. What will be dp of I comma 1? So to calculate dp of I comma 1, we are selecting current segment. So now let's say initially we would have selected, like initially we have sorted our segments. Why I'm sorting segments, like I'll tell you in a moment. So currently we have I, and then we'll try to match this segment with any of the segments that are appearing after this. And now I have sorted this because first of all, I'll have to check whether I or j intersect or not. If I and j are not intersecting, then anyway, I cannot select I and pair it with j, right? So first of all, if I and j intersect and I'm selecting I, so I can select j also, pair it with j, and all of the segments that appeared in between would have to be removed. That's why I would have initially sorted my segments according to this starting or left boundaries. So these need to be removed. Then my solution is pretty simple. Like if you're dp of I, so dp of I comma 1 can be calculated. Since you're selecting the current segment, find for all the j's from I plus 1 to n minus 1, try to see whether or not the jth segment and the ith segment intersect. If they intersect, just simply get the maximum value of dp of I comma 1 will be nothing but maximum of dp of I comma 1 comma 2 plus 2 is from, like I have selected two segments, right? I and j, these are intersecting. So 2 plus, again, that's dp of j plus 1. Now, I cannot do j plus 1 here. Why? Because after this also, there can be some segments that are intersecting with this, right? Like this. Suppose my j was this. So there are some segments after this also that are intersecting. So I have to remove all of those segments. So let's say at kth place, I have got the first time, like this segment is not intersecting with my jth segment. So dp of k comma 0, maximum of dp of k comma 0 comma dp of k comma 1. So this is my complete solution. 2 plus maximum of this thing. dp of I comma 1 will be nothing but maximum of dp of I comma 1 plus dp of I comma 1 comma 2 plus 2 is because I have selected I and jth segment, I comma j, then maximum of dp of k comma 0 and k comma 1. So let's look at the implementation.
But all the segments between I and j will intersect I.
Yeah, you have to remove those. So this is the implementation. The implementation is pretty simple. First of all, sort the segments. Then this is my dp n comma 2, and 2 is because for each I you have two options, whether to select it or not select it. So initially each of the values is -1. Then in my DP, like finally, like I said, my answer would be n minus maximum of solve 0, 0. This means starting from the 0th segment, 0th index segment, I'm not selecting it, and 0, 1 means starting from the 0th index segment, I'm selecting it. So then I'm calling my solve function. If my current index is equals to n, I'm simply returning 0. If otherwise, if I would have earlier calculated this value I, and for this DP of I and selected, I'll simply return that value. Then I'm checking if my current selected is 0. That is not, if I'm not selecting the current element or current segment, I'll simply return the maximum of I plus 1, 1 and I plus 1, 0. That is for starting from the next segment. If I select it or if I don't select it, what is the maximum that I can get? Otherwise, if I'm selecting the current segment, what I'll have to do, I'm simply like this val, this value is basically I'm getting the maximum for each of the j's. I'm trying, if the current is j is equals to I plus 1 and j is less than it, I'm checking whether or not my segment I and j intersect. This is the condition for checking that my segments I and j intersect. So if once they intersect, what I can do, I'm then checking till which place I have to remove the segments, because all these segments that are intersecting with j, I cannot take those segments also. So removing those segments, after that, my value will be maximum of val, comma. You can simply do dp of I, comma selected also here instead of val. So dp of I, comma selected will be maximum of dp of I, comma selected, comma 2 plus maximum of when the kth, starting from the kth segment, when it was selected or when it was not selected. Finally return this value, and whatever the value that you get here, subtract it. Maximum of these two will be subtracted from n, and that is your answer. So it's clear.
But we can select any of between I and j, one, and remove others.
Yeah, so I'm checking for each of those, right? For j, like look at this, j is going from actually I plus 1 to n. So I'm checking for each of those segments. Whichever intersected with I, I'm checking for all of those segments. Like that is how DP works, right? This is not a greedy solution. Greedy, like in greedy, you try to fix and then move forward. In DP, you don't actually know, okay, what will give you the most optimal value. So you're checking for everything.
Yes.
Okay. So that's it. I think we can stop now. If you don't have any doubts, you can leave this meet. Thank you.